Good morning, GM. Thank you, everybody here, for choosing to spend your time at our third inaugural NoirCon.
Okay. Hello, everyone. My name is Kite. I'm a research scientist at Uniswap Labs. I'm very excited to share with continuous clearing auctions with you guys today. We are very excited about continuous clearing auction because we are really exploring these new mechanisms for these new price discovery ways and fair on-chain participations. The issues with new and low liquidity tokens are looking to build liquidity. But this is primarily occurring on centralized exchanges before. With extractive fees, we have talked to a lot of teams that have in the past listed on centralized exchanges. Centralized exchanges can charge up towards 10% of the token supply just to work with them. This is in separations of the professional market makers deal. The professional market makers also ask to take a large economics gains from these teams. The initial liquidity is often provided by these market makers. Usually, they do the system that they have. The team is going to loan some of tokens towards these market makers, and they're trying to manage the initial price when it's listing on centralized exchange. But the issue is the market makers basically is in the role of dumping the tokens. Whenever there are any buy pressures, they're just going to sell the tokens for these teams. It's also very opaque in agreements that these are all of the details with the 10% I just told you, the market makers deals. These are all opaque agreements. It's often unclear what's the details behind the launch. Usually this is biased towards insiders, and there's just like a lot of uncleared agreements behind the scenes. So these opaque markets with extractive middlemen. So ideally, on-chain solves this, right? However, what we do see is that out of all the current on-chain liquidity bootstrapping models, there are all shortcomings. Let me try to go through them one by one. When we think about airdrops, I guess the first word I'm thinking is like bot farming, immediate dumping, zero price discovery. So there are academic research that are published in top finance journals, study all these in the past of the airdrop events. So what they found is that all of these airdrop events usually ends up with, at the beginning of the market, up to 2/3 of the tokens are dumped immediately. Usually these are not long-term users. The average hold time of these tokens that got airdropped is very short. And these really disrupt the market when the market actually starts the secondary markets. And these airdrop, because these are zero price sales, what happened is that whatever launch price of the market is not market tested. That means that it's going to be highly disrupted. So airdrop is really not a good way to launch tokens. When we think about fixed price sales, these are more common. These are all the common IPOs that we see these days. But if we really think about fixed price sales, the one issue with fixed price sales is what is that fixed price should be. I think that might be the hardest question for some of these teams that ever do these sales, is that what the price should be. There are two scenarios, almost only two scenarios. You can argue that there's three. The one scenario is if you overprice the token. Right? If you overprice the tokens, what happens is that people will not like to buy at this fixed price, but it's already fixed, so there's nothing you can do. Then what's going on is you're going to be a lot undersubscribed. This is what happened these days. The large one SL that we're looking at, that their valuation is very high, and then they're having troubles to fully subscribe to the 100%. Now, the second scenario is that what happens if you underprice it, right? If you just price it super cheap, like what we see in the Mega Easy example. They just price everything super cheap. What that would happen is that it will be super highly oversubscribed. People will commit so many ETH into these sales, which is very inefficient systems. And people who want to actually buy these tokens at a higher price are not able to do it. You can argue there's a third case that the fixed price, the price is exactly at demand. You can almost imagine I have a price lane here, and then somewhere in the middle there's a perfect point, and then you're throwing a dart, and then it hits the perfect point. It's very hard. It's never happened. So that's the issues with fixed price sales. You either overprice it or you underprice it, which cause undersubscription or oversubscription. Now, there are other methods, for example, Dutch auctions. In Dutch auctions, these are slightly more complicated auctions that usually the price goes from up to down, the price drops over time. Some people do uniform price clearing, some people do pay-as-you-go prices. But in general, these types of auctions are very complicated. In the equilibrium, in the economics game theory strategies, the idea is that you want to wait. You want to wait until more information comes in to make sure informations. One example is that when Google did their IPO, they did this kind of Dutch auctions, fixed price. Everyone just put their bid in. It's kind of like a Dutch way, and then at the end, they will clear at the same price. The issue with that, and there's research paper on, about this, is that with these kind of auction, people just wait until the last seconds because there's really no incentive for them to review information early on. That creates a problem because that's an inefficient information review. So what that means is that these are people are usually doing strategic waiting. These are professional will dominates these auctions. So that's the issues with Dutch auctions. And then we have our lovely bonding curves that a lot of the on-chain methods are trying to solve. The issue with those is they are one-time settlement. That means they're very easily be exploited by MVVs. These are very time-sensitive. We see on pump.fun the seconds a market opens, there's a bots coming in. Whenever someone buys, they dump it on them immediately. So these are all, the common thread of all of these methods we see is that these existing mechanism rewards timing and rewards some kind of sophistications over genuine valuation, genuine belief on the projects, on these liquidity. So these create opportunity for manipulations. Very easy for people to manipulate this market such that it's really hard to get immediate sustainable liquidity once we finish these initial liquidity bootstrapping. So that's why we have come up with the CCA, the continuous clearing auctions. So what we want is we want a better on-chain approach, which we want to prioritize fairness, transparency, credibility, price discovery, on-chain liquidity, and decentralizations. So what we mean for each of them is we want these competitions, these auctions, to be on valuations, not just time or technical sophistications. We just want, at this level, we want the fairness that everyone has a fair evaluations of the tokens. If the clearing price is going to be below them, they should be able to get the tokens. There should be transparency. There should be real-time visibility into price discovery. We don't want off-chain settlements. We want on-chain information that people can actually see the transparent information all the time. We want credible price discovery. Whatever price set in those fixed price sales are very opaque. We have no idea how these prices comes up. But in CCA, we're going to find the final price reflects the actual demand that goes into this auction, and there shouldn't be any manipulation on that price. We want at the end of the day, there will be on-chain liquidity, the secondary market, that we have a deep liquidity. That's why we want some seamless trading with sufficient depth into on-chain trading liquid environment. And we want some decentralizations. We want no gatekeeping. So this is why this is what this Uniswap CCA protocol has delivers. We claim that we will fit all of these. And then in order to tell you how we do that, let's maybe walk you through a very simplified example of how this auction actually works. All right, let's imagine this is our setup. The token team is supplying 1,000 tokens over a four-block auction. So this is only 4 blocks. Let's simplify this. The team is supplying 1,000 tokens. We have 4 blocks. Each block has 250 tokens. Okay, so in the first block, we're going to try to clear 250, the second block 250, third block 250, and then the last one is the same. All right, so that's our setup. That's from the team side. What the users need to do, what these user action is that they are going to, at any time of these auctions, they are going to bid with their budget and their max willingness to pay price. So here, for example, we have Alex. Alex is saying, OK, my budget is $800, and I would like to participate in this if the price is under 3. All right, so that's all Alice has to do. All the rest are going to be the protocol mechanics. Okay, all the rest is going to be handled by the smart contract. So what does the smart contract do? What does the protocol do? The protocol is first going to spread across all future auction blocks for Alice. What that means is that there are 4 blocks remaining in the auction. What the protocol is going to do is it's going to split the 800 Alice budget into 200, 200, 200, 200. Each with the same max price of $3. Now, where do I got the 200 from? So the $3 is the same max price that Alice has been saying about $3. Where does the 200 come from? The 200 is, I write 800 times 1/4. Now 800 is the 800 we see that Alice's budget is, but where does the 1/4 come from? So the 1/4 is basically, there's 1,000 tokens from the team. 250 is going to sell in this period. Then basically that's 1/4 of the tokens that the team is going to supply. That's where we got 1/4. So that's how we split Alice's budget, $800 budget, into four 400s across 4 different blocks. OK, now what the protocol is going to do is protocol is going to define Alice ask in this block. OK, now let's zoom in. Let's really zoom into that first block. Okay, we're only looking at that first block where there's 200 budget and then 300. What happens there? Let's define the ask. Let's define the what Alice is asking. Okay, let's imagine. It's a little blurry, isn't it? Okay, let's look at this point. What this point means is that if we're going to settle at $1, Alice's budget is $200. That means Alice would like to get 200 tokens. If the price end up to be $1, Alice wants 200 tokens. What about if the price is $2, which is this point? If the price is $2, then Alice has a budget of 200, then Alice wants 100 tokens. All right, so it's just we're just expressing that in every single point. What happened? What does Alice want? And remember, Alice says, I would not participate if the price is above 3. Okay, so at any point down there that says the price is more than 3, like say $4, then Alice wants nothing. Right? Alice do not want to buy anymore because the price is way too high now. Okay, so we can draw this nice line that says for every single point that is a price with some tokens numbers that Alice wants. All right, so this line is simply as the price times the quantity equals to the budget Alice has. Okay, so this is Alice, and we can nicely define Alice's want. Let's say there's a second person, right? There's a Bob also bids in this auction. Bob has a lower budget, $600, but Bob is thinking that the fair price should be $4. So Bob says, if the price is going to above $4, I'm not going to participate. But if the price is below $4, I'm willing to buy. So similar to what we do to Alice, that we draw this little pink line, we can also draw the line for Bob, which is Bob's willingness. At each point, at each price, we can know how much Bob wants. So the protocol has handled all of these. The user doesn't have to do any of these. The user only have to specify their budget and their max price. Then what the protocol is going to do is, because we know each person's want, right? We can wellly define each person's want. We can define what aggregate want is. What that means is that, for example, if we look at that $1 mark again, right? So let's $2 mark. At $2, what happens? If the price is at $2, Alice wants 100 units, and Bob wants 75 units. So the total of 2 of them, they want 175 units of tokens. So we can define these all wants in this black line, basically. If the price is above $3, then only Bob's ones is there. Otherwise, we have both of them. All right, so we can define these in the protocol. This is how we aggregate all the active bits in this block. Again, this is only the first block in this first block. And this will be the overall demand for this block for Bob and Alice. So now recall that what we have is we have this supply from the team. Right? The team says there's 1,000 tokens. We're going to split them into 250, 250, 250, 250. Now in this block, in this first block, how many tokens do we want to release is 250. Right? So we're going to cross-reference the supply in this block, which is that blue line I'm drawing right now. That's how many tokens we're going to release in this block. So you will find a nice intersection point on this graph. It's always well-defined intersection point. It's guaranteed it always exists for any demand and supply curve that looks like this. And you can find this nice little point is at 1.4. What that means is that if we set the price at $1.4, then aggregate want is 250 units. And the supply is also 250 units. And then we find a perfect equilibrium price that the demand and supply just perfectly match with each other at this point. Again, this is only for block one. So what happened in this block one would be, this is a lot to read. I'm just going to describe you what's happening. In this first block, we have Alice and Bob. They put in some budgets. They put in some max price. The protocol will try to find a price that clears all the tokens, and that clearing price will be $1.4. In this case, Alice is going to spend all her $200 in this period, and then she's going to get 142 point something tokens, and then Bob is going to get 107 point something tokens, and the total of them is going to be 250 tokens. So this is what happened in this one block. And then the protocol is going to say, let me continue doing that until we run the full auction, right? So in each of the block, what I just described happens at the protocol level. We're going to try to find a clearing price. We're going to clear these tokens to these users. Something I want to point out, at some point, for example, at this block 3, at some point, maybe we find that the clearing price has to be above $3. What that means is that that's above Alice wants, right? So at some point, Alice will stop getting filled because the clearing price is above her max willingness to pay. But if you look at the columns, the rows before, you can still see that Alice got some fillings before we went out of her range. So she's going to still get some tokens when we were clearing below his maximum willing to pay. I'm not going to go through all the details in this table, but I just want to skip to here. The mechanism, the smart contract, is going to do it for every single block that we see, that we have in the auctions. So the actual, usually the auction is going to be much longer than only 4 blocks within a minute. So usually that's going to be much longer. So our smart contract engineers are brilliant to design the system such that it's very efficient to run all of these demand and supply I just described to you, very efficiently solving on chain. Now, this is the result of this auction if we run out of the 4 blocks later. So what happened is that you can see Alice want 800. Budget was 800. She only got to spend 400 because at some point, right, the filling price is above Alice wants, so we stopped filling Alice. But she still got to spend $400. She still got 233 tokens at some lower price. So something I want to highlight of this result is that lower bids still get allocations, right? Like I explained, Alice still gets some allocations, even though she has low valuations. And it went over her price mid-auctions. The second thing is that if you bid early, there's this early bidding incentive that if you bid early, you're more likely to clear those lower prices clearings. Thus, your average price is going to be lower. If you look at Alice and Bob's price here, they're being lower than Carol and Dave, which Carol and Dave enter in block 2 and 3. So they enter later in the auctions. That's why this Alice and Bob get a better average price, because they enter early. That's the early incentives, early bidding incentives. Another thing I want to point out is that for the large but late group, right? If the Dave enter at the last, maybe the third block, with a huge order of $12,000. So these, if you want to think about them as like whales, if they want to hold their information until the very last minute, what would happen is that their clearing price, they will still get the tokens, but their clearing price is going to be above the early arrivers of Alice and Bob. So they can't really dump at this point if that's what they're doing. Wait until the last minute, try to snipe or try to like place in a big order and then try to dump on people. So that's not something they can do in this auction. So that's the overall of how like one auction will do. Most of it is how the protocol is going to handle this. The user only have to specify their budget and their max price. And from the team perspective, all they need to do is to specify some of the parameters we have set for the auctions, like for each block, how many tokens are getting released, how long the release period should be. So overall, these are very incentive compatible, which means that if you have some information about the fair value of these tokens, and then you should probably just be truthfully reporting those. Yeah, okay, cool. So, any questions? Yes?
How come we use the clearance price instead of a higher price? Because if there's demand for paying more, why do we do $3 from Alice instead of like 4 or 5? Is it you go from top to down, like probably there's an iteration like a for loop at a certain point.
Right, great question. Okay, cool. So let's take this graph as an example. I was saying that, hey, let's clear at 1.4. But Alice is willing to pay at $3, right? So why don't we just clear at $3? So the issue with that is that if we're clearing at $3, Alice has a budget of $200 in this block. So we will give Alice 66 tokens. Okay? Okay, and then how about Bob? Bob has $150, and at $3, then we give them 50 tokens. So that's a total of 116 tokens. But then we have more tokens that we want to release, which is 250, than the ones that we can actually go out. So that's why we don't clear at the highest price possible, but at a price that demands perfectly matched supply. Oh, I see. Okay, right. So let me try to rephrase, and then you tell me if I'm correct. How do we actually do this search in the smart contract? Okay. Do you want to take this question, Eric?
Hi. I don't know if this works, but I can just speak loudly. I'm an engineer at Uniswap, so we worked on this together. The search is done every time somebody new enters the auction. You can see that from Kite's example, the actual curve only really changed when Bob joined. If Alice is the only participant, the curve doesn't change. So when somebody new enters the auction, we basically take the current price. We know that the next price will tend to be closer to the current price than some arbitrary price in the future. So we basically look at the points on the graph where people have specified their max willingness to pay. And we just check, can we move the price up to there? And if we can, then we keep going. If we can't, then we find a price in between. And we basically show that the operation is O of n on the number of discovered prices in the auction. not on the number of participants.
But then how do you, when do you cut Alice out of it?
When the price exceeds her max participant.
Yeah, but then the total amount of demand is also going to be cut by that, right?
Well, the price would only increase above that if there was other demand taking her place.
Yeah.
Yeah. So the actual collective participating demand does not increase.
Only increases if she's going out or she's staying.
Yeah. But she would only get kicked out of the auction if somebody else had taken her place.
All right, thank you, Eric. Any other questions? This is the point of time you're wondering if you just explain it too well or you explain it really bad such that no one can even ask a question. Yes.
What would the ideal strategy be as a participant?
I think the ideal strategy should be if you have some understanding of what you think the fair value is, like you have this idea of what the max price should be, you should try to bid early in the auctions. If you don't, I guess there's two options. One is that you can wait and see some information comes in. You can see some other people's bids coming in. That's some information revealed to you, and then you know more information about this auction. Then you can enter the auctions with some max price. Or, however, there's a trade-off with waiting. That's because there's an incentive to early bids, and if you wait, the average clearing price will be higher. But that's the kind of the cost for you to receive information from other bids. But if you already know what the fair evaluation or what the max willingness to pay price you have, it's just to enter as early as possible. Yes. Yes, Aztec is currently doing for their token distributions using CCA. What is it? It is Solidity. It's Solidity. Yes, there.
What's the idea behind having all these multiple blocks instead of just the one? And also, like, could you? I mean, my understanding is that you have like these three blocks going on. Could you have a continuous mechanism there?
Right. Okay. So to answer the first question was what's the idea behind why do we do it like multiple ones but not just doing it at once? So the idea is that if we all do it at once, like that kind of like collapse to like a standard uniform price auctions. The issue there is that you would never have people enter the auction before the last second, right? Because there's really no benefits for you to enter the auction early. So there's really no information to learn anything about, and everyone just wait until last minute. So there's a couple of issues with that. First issue is you have this gas wall that people are trying to get into the last minute. And then imagine a whale just come in the last minute. You would have thought that you would get some clearing price, but someone just bids, and then the price just skyrockets. And it was like, I don't really want to do this. So that's one. And then the second thing is, because of this, because everyone trying to do it at last minute in the game theory outcomes, then the price discovery is really inefficient because your information is not coming in continuously, smoothly, but all at once. So that's the reason why we want to do this like multiple waves and continuously. Now the second part of the question you ask, why can we do something like continuous? Like why does this blocks? So these are just like simple examples of what happens, but for discrete blocks. But in reality, when you actually launch what Aztecs are doing right now, everything should be continuously. That means that every single block is like a small percentage, but it continuously clearing some, and then everyone's demand is also spread across all the time in between this auction.
So like blocks are like just like a block in the auction is like a block in Ethereum.
Yes. Yes, a block in the auction right here is just a block in Ethereum. And if you do it on Unichain, it will be just a block on Unichain, which is going to be very fast. All right, I think I'm on time. Thank you, everyone, from attending. You can find me, and then we can chat offline if you have any other questions. Thank you.